Okay, so in lesson 5.7, we need to find the values of x and y if 3x plus 4y equals 6 and y equals 2x plus 7. So what we're going to do is we're going to take this information and substitute it in here. So what they're telling us is that y is 2x plus 7. So for this first equation, everywhere that I see a y, I'm going to replace it with 2x plus 7. And what that does is it gets rid of that variable so that we can solve this equation. So, and it's important to put it in parentheses, so don't forget the parentheses. All right, so I'm going to solve now, and I can because I have one single variable, x, distributing, combining like terms, subtract 28 on both sides, divide by 11, x is negative 2. So the direction says to find the values of x and y, so we've only found x. So what I'm going to do is I'm going to take this and go back to this equation up here and plug it in for x. So y is going to be equal to 2 times the negative 2 that we found. And then y is going to be negative 4 plus 7. And then y is equaling to be a 3. So we have now solved the equation. You don't have to do this, but it'd be great if you did. Not really required. Your final answer should be in coordinate form. So whatever the first variable was, you're going to put it first, and the second one is second. Not necessary, but as a grader, greatly appreciated. Okay, we're going to do the same thing here. So for y now, I'm going to plug in negative x plus 1. Going to distribute. Combine my like terms. Subtract 3 on both sides. Divide by negative 1. And x is negative 2. I'm going to go back here and plug that in. And that's going to be 2 plus 1, which is 3. And then again, you can write it this way, which I would really appreciate it, but not necessary. Okay, we're going to do the same thing. 2x plus 7 parentheses x minus 4 equals 8. I'm going to distribute. Combine like terms. Add 28 on both sides. Divide by 9. X equals 4. I'm going to plug that in here. And y is 0. Get 4, 0. All right, so the next one is our favorite from fractions, and let's just plug in and see what it looks like. So I have 3x plus, and then all this, x over 3 minus 4 over 3 all over 2 equals negative 1. So here it looks kind of disastrous. We have all this stuff going on. So what I want to do is take care of this guy here, that 2. So what I'm going to do is I'm going to multiply 2 on both sides to get rid of that 2. Now 3x plus x over 3 minus 4 over 3 equals negative 2. Okay, so now it's kind of looking a little better. I'm going to use my LCM trick. Multiply by 3. So again, 9x plus x minus 4 equals negative 6. Combine my like terms. I feel like we're back to a little bit of normalcy now. Add 4 on both sides. 10x is equal to negative 2. Running out of room here, so I'm going to rewrite it here. Divide by 10. X is equal to negative 1/5. All right, so now I have to plug that back into this guy right here. So I have negative 1/5 over 3 minus 4/3. So I need to do some side work for this guy, and hopefully you have this down already. So I just need some more room. So I'm going to get rid of the work from before And my side work will be negative 1/3 divided by 3. Keep change, and that's negative 1/9. So all this is negative 1/9 minus 4/3, and that's going to be common denominator times 12, and get negative 13/9, and that's going to be my y answer. So negative 1/5, comma, negative 13/9. Okay, so lesson 5.8 is solving systems of equations, and that's just a really fancy word for two equations that work together. So I have a top equation here and a bottom equation. In our previous lesson, we were actually dealing with systems, but it was really nice because it was like saying y is equal to this whole thing, and we substituted in. But if you look at these two equations, we don't have that. So what we have is two ways to solve this. You can Google the other way, which is substitution method. I don't recommend it only because it takes really long and it can be a little confusing. So I'm going to show you the elimination method and how to solve this system. I also believe substitution method is also in your textbook, so if you want to look there first, you're more than welcome to. All right, so in the elimination method, the goal is to eliminate one of the variables. I'm going to eliminate the y variable because there's a plus sign here and a minus sign here. That's really key because to eliminate something, you need the positive and negative of that same number. So positive, 5 minus 5, we know that's going to be 0 because this was positive and this was negative, and the numbers are the same. And so that is the concept here. So if we take a look at this, I have a 4y and a 2y. If I were to combine that, that would not be 0. 4 minus 2 is a 2. So what I'm going to do is I'm going to multiply the whole bottom equation by 2. And watch what happens. The top equation stays the same. The bottom equation gets multiplied by 2. And then take a look at what just happened. If I were to combine those, that would be 0. And that's what gets eliminated. And that's really the elimination method in action. And so I'm going to draw a big line and combine everything vertically. So 3x and 2x is going to be 5x. 6 minus 16 is negative 10. Divide both sides by 5. And then x equals negative 2. Just like in the previous lesson, I have to plug that back in to find out what y is. So I'm going to take this bottom equation and substitute negative 2 for x, and I'm going to solve for y. Divide by negative 2, and y is equal to 3. I get negative 2, 3. So in class, I usually get this question, well, why didn't you eliminate the x's? Again, I'm going to erase my little marks here. I kind of went for the y's because the signs were different. Now, that's not to say that you couldn't eliminate the x's. We could have totally multiplied this bottom one by negative 3. And what would have happened is the x's would have eliminated. So you have an option of eliminating the x or the y. I chose to eliminate the y's because it was easier just to multiply by 2. But if you want to test it out right now, you can go ahead. Negative 3 will work for this problem, and you will get the same answer. Your work will look a little different, but your outcome will still be the same. So you can eliminate either variable. Okay, so you can solve this by eliminating the x's or the y's. If you notice for the x's, they're two different numbers. So what you can do is you can multiply the top one by 2 and the bottom one by 3. And what's going to happen is both of them will turn into 6, where one is negative and one is positive, and then the x's will eliminate. So if you wanted to do it that way, you totally can. I'm actually going to multiply the top one by -2 because my goal here is to eliminate the y's. So again, if you wanted to eliminate the x's, you would multiply both equations. So sometimes we're kind of forced to do it that way, but if I had a choice, I would just multiply one equation for less work. And so that's what I'm going to do. So I'm going to multiply by -2. Bottom equation stays the same. This gets eliminated, and I get 8x is equal to 1, and I get 1/8 for x. Okay, I have a feeling that this is going to be a fraction answer for the second one. And so I'm going to use the bottom equation. I'm going to plug in 1/8 because that's what we just found. And that's going to be 1/4 plus 2y equals. Now, I'm actually going to change the 5 to 20 over 4 because I know I'm going to have to do a common denominator because watch, when I subtract 1/4, I would have had to do that anyways. So you can keep it as 5 and then do side work. It's up to you. I like to do it right in the problem. And then this is 19 over 4 multiplied by the reciprocal, which is 1/2. And then y equals 19 over 8. Okay, so then I get 1/8 for x and 19 over 8 for y. Okay, I'm going to multiply the bottom by -2 because I want to eliminate the y's. So top equation, no change. And this will be x equals 1. Plug in 1 for the bottom equation. You can plug it to the top if you want. It doesn't matter. You'll still get the same answer. And subtract 2. And y equals -1. So I get 1, -1. Okay, the next one, I'm actually going to multiply the bottom equation by 3 because I want to eliminate the x's. I'm going to move my work up here just in case it runs into the other one. Multiply by 3. And then the x's will get eliminated. Divide by 22. Y equals 1. And then I'm going to plug in y equals 1 for the bottom equation. And then solve for x. Oops, subtract 5. And then that's -2, divided by -1. X is equal to 2. So then my answer is 2, 1. We got y first, so just if you do it this way, which is writing in coordinate form, make sure you put x first. All right, so 5, 9 is the same as before, but with fractions, your favorite friend. So I'm actually going to distribute that half, and that's going to be x plus 1/2 y equals 3x minus 1. And then what I'm going to do is I'm going to bring all the x's to one side. That'd be -2x plus 1/2 y equals -1. So for systems, we want to keep it in this form where x is first, then y, and it's equal to some number. So that's what happened to this first equation. That's what it's going to turn into. So now the bottom equation, I'm going to multiply both sides by 3. And that will be x plus y equals 3 parentheses y minus x. Distribute the 3. And then I'm going to bring everything to the left side. We have 4x minus 2y equals 0. So the second equation became this. So what I'm really doing is I'm like simplifying the original equation, and then I want to keep it in, this is called, by the way, standard form, where x and y is on one side and a number is on the other side. And what I'm going to do now is I'm going to write it over on top of each other like a system. So this is going to be -2x plus 1/2 y equals -1. And then this is going to be 4x minus 2y equals 0. So now what I want to do is try to eliminate one of these things. And I don't like that fraction, but I can change that fraction to a 2 by multiplying it by 4. And what will happen is the y's will both be 2 with different signs. So I'm going to multiply the top one by, what did I say? 4. So this will be negative 8x plus 2y equals negative 4. Again, I kind of went for that because I didn't want to work with that fraction. And then the bottom will stay the same. And then what will happen, the y's will get eliminated. Negative 4x equals negative 4. And all that craziness turns into a nice whole number for us, x equals 1. I definitely don't want to plug it back into these guys because they're just, I feel like it's going to be too messy. So what I'm going to do instead is make my life easier and plug it back into this guy. So when I plug it in there, 4 minus 2y equals 0. Subtract 4 on both sides. Negative 2y equals negative 4. And we couldn't, oh, okay, I thought we were going to get a fraction. And so y equals 2. So all that became 1, 2 for our answer. And again, you can write it like that if you want. So yeah, I know this is not very friendly, but just to recap what I did is I changed the original problem. I kind of distributed, see what I could like make a little bit easier, and then I kind of created my own version of it, which was right here. Alrighty, so for this one, I'm going to use the LCM trick. Multiply this by 2, and then multiply this by 4. So this will be x plus 2y equals negative 1. And then this will be 12x equals x plus y plus 12. All right, so the top equation is in standard form, but the bottom one, I have to kind of work it out a little bit. And so that's going to be 11x minus y equals 12. So now I have this as my first equation, and this is my bottom equation. Both are now in standard form. So I'm going to put them on top of each other. And then what I want is for the y's to eliminate, because all I have to do is multiply the bottom one by 2. And so then the top equation stays the same. Bottom 22x minus 2y equals 24. So this is going to be 23x equals 23, divided by 23 on both sides. X is 1. And so I'm going to plug that into this top equation. So that's going to be 1 plus 2y equals negative 1. Subtract 1 on both sides. 2y equals negative 2. Divide by 2. And y is equal to negative 1. So my answer is 1, negative 1. Okay, same thing here. I'm going to use the LCM trick. Multiply by 6, and then multiply this by 3. Okay, so this will be 3x plus 2y equals 1, and then 2x minus y equals 3. Lucky for us, this is now in standard form. I'm going to multiply the bottom equation by 2, and that's going to eliminate the y's for me. So I have 3x plus 2y equals 1. That doesn't change. Then distribute the 2. And the y's will eliminate, so I get 7x is 7x is equal to 7, and x equals 1. I'm going to plug that back into this second equation here. Looks a little bit easier. And then that's going to be 2 minus y equals 3. I'm going to subtract 2 on both sides. Negative y equals 1. Divide by negative 1. Y equals negative 1. So my answer is 1, negative 1. All right, so this next one looks not fun. But luckily, our denominators aren't too bad. So I'm going to multiply this top one by 3. And then this bottom one by, bottom one's going to be multiplied by 2. All right, so when I do that, I'll get x plus 2y equals 3x minus 3y minus 4. The bottom will be negative 2x equals 3y plus 1 minus 5. All right, so now I want to bring everything to one side. So this is kind of going to get messy. So what I'm going to do is the first equation I'm going to write over here. And then the second one I'm going to write here so that I can show you my work kind of organized. All right, so for this one, I'm going to subtract 3x and add 3y on both sides. And so that's going to be negative 2x plus 5y equals negative 4. So now that's in standard form. Okay, so the next one, I'm going to subtract 3y. And I'll get negative 2x minus 3y equals negative 4. And the negative 4 was combining my like terms. And so now that's in standard form. So what I'm going to do now is put them on top of each other. And I'm going to, it looks like I'm going to eliminate the x's. So for the x's, what's really neat about them is the numbers are the same, but the signs are different. So what I'm going to do is I'm going to multiply the bottom one by negative 1 to get them to be different signs. So the top equation stays the same, and the bottom equation, all the signs will change because I'm multiplying by negative 1. The x's will now eliminate, and I get 8y is equal to 0. Divide both sides by 8. Sorry, I'm running out of room down here. And y equals 0. All right, so I'm going to plug in y equals 0 for this one since it's kind of up there already for me. So negative 2x minus 3 times 0 equals negative 4. And then negative 2x, that's just 0, so that just goes away. And divide both sides by negative 2, and then x is equal to 2. And so the answer would be 2, 0, because we solve for x second. Or again, you can just leave it like that.